Hello, everyone. My name is Akshat Thakur, and today we are going to understand the questions that were asked in our data science first internals. So let's start the section A. Actually, the question paper has four parts: part A, part B, part C, and part D. So let's start part A. First question: three more commonly used statistical in measures for characterizing depression in student feedback form. And the faculty rating or peer evaluation discuss how these measures can efficiently in the large student database. Okay, so part A is statistical characterization of feedback data. Let's go through the solution. So measures of depressions and efficient computation. So what are the measures? First is range, maximum और minimum का जो difference होता है उसे range बोलते हैं. And second is interquartile range IQR. So थर्ड क्वाड्रेंट और फर्स्ट क्वाड्रेंट का जो डिफरेंस होगा वो IQR कहलाएगा. Standard deviation or variance measures average deviation from the mean, most commonly used. Okay, so this is the favorite of data science. Computing in large database issues. We cannot load terabytes of data into them. Computing in large database के अंदर issues क्या आते हैं कि we cannot load terabytes of data in RAM. Solution: we use distribution method, algebraic manipulation. Instead of scanning data multiple times, we maintain three running sums. First is count, second is sum of values, and third is sum of squares. So the formula is standard deviation is equals to sum of squares divided by number count minus uh, sum of values divided by number into 2. So this is the formula of standard deviation. Suppose that student feedback on faculty mentoring effectiveness is giving in the sorted order. The order is 13, 15, 16, 16, 19, 20, 20 up to 52, 70. What is the mean rating? What is median? What is mode of the data? Let's start with A part only. Mean अपन सबको पता है. Sum of xi upon sum of fi मतलब जितने भी वो है उन सबका सम करके नंबर ऑफ जितने भी इवेंट्स जितनी भी फ्रीक्वेंसीज है उनका सम करके नंबर ऑफ फ्रीक्वेंसीज वो मीन है. और मीडियन मतलब मिडिल मोस्ट नंबर और मोड मतलब सबसे ज्यादा बार जो आया है वो. सो न्यूमेरिक प्रॉब्लम मीन सॉर्टेड फॉर्म में है, सॉर्ट करने की जरूरत नहीं है. टोटल काउंट तो है 26 है तो अपना n की वैल्यू 26 आ गई. इवन नंबर इसलिए लिखा है क्योंकि मीडियन का फॉर्मूला इवन और ऑड पे डिफर डिफर करता है. मीन के लिए सिंपल सम ऑफ वैल्यूज अपॉन टोटल नंबर ऑफ वैल्यू. सम जो रहेगा इसका 774 आएगा. टोटल नंबर ऑफ वैल्यू 726 है तो मीन अपना अप्रोक्सीमेटली 29.77 आएगा. मोड सबसे ज्यादा बार क्या आ रहा है? इफ यू हैव नोटिस सबसे ज्यादा बार 25 आ रहा है. 22 दो बार है, 25 1 2 3 4, 30 एक बार, 33 दो बार, 35 तीन बार. सो सबसे मैक्सिमम जो फ्रीक्वेंसी है वो है 25 की. तो 25 विल बी आवर मोड. मोडैलिटी जो रहेगी इसकी जो कि इसमें सिंगल मोड आ रहा है तो इसको अपन यूनिमोडल बोलेंगे. अगर मल्टीपल मोड रहते तो उसको अलग अलग बोलते हैं बट सिंगल मोड के लिए वी यूज यूनिमोडल. मीडियन n बाय टू टर्म प्लस n प्लस वन बाय टू टर्म और इन दोनों जो टर्म आएगी वो हमारा रहेगा मीडियन. ओके. और अगर सिंपल सा वो होता तो अगर ऑड नंबर रहता तो अपन क्या करते? सपोज 27 होता, 27 प्लस वन बाई टू, 28 बाई टू 14. 14 टर्म जो रहती है अपनी दैट विल बी आर मीडियन. बट यहाँ पे जैसे इवन है तो वी यूज इवन फॉर्मूला तो मीडियन टर्म विल बी 25 एंड 25. क्वार्टाइल्स जो रहेंगे, फर्स्ट क्वार्टाइल्स द वैल्यू एट पोजीशन n प्लस वन बाय फोर. n प्लस वन कितना है? 26 प्लस वन 27 बाय फोर 26 6.75. Interpolation between sixth term 20 and seventh term 20. दोनों 20 20 है. Q1 is 20. थर्ड क्वार्टाइल जो रहेगा द वैल्यू पोजीशन 3 n प्लस वन बाय फोर. वहाँ पे n प्लस वन बाय फोर था, यहाँ पे थर्ड क्वार्टाइल क्वाड्रेंट है तो 3 आ जाए मल्टीप्लाई बाय 3. तो 60.6.75 इंटू 3 20.25. तो इन दोनों का डिफरेंस जो रहेगा Q1 और Q2, Q1 और Q3 का वो अपना इंटरक्वार्टाइल IQR रहेगा. इंटरक्वार्टाइल जस्ट गोइंग थ्रू द फुल फॉर्म इंटरक्वार्टाइल रेंज. ओके, सो 6.75 20.25 minus 6.75 विल बी, बट अभी थर्ड जो रहेगा हमारा वो नहीं निकला था। Q1 जो है दैट्स अ सिक्स्थ टर्म इंटरपोलेशन, सिक्स्थ टर्म है ये, सिक्स्थ और सेवन टर्म जो कि सेम थी। अब यहाँ पे जो इसका है 20.25 आया है, तो 20 और 21 फर्स्ट टर्म हम देखेंगे, 35 और 36। अब जो कि ऊपर तो सेम आया था तो अपन ने एक टर्म आ गई थी Q1, यहाँ पे अलग अलग से। सो व्हाट विल डू, विल जस्ट सब्सट्रैक्ट इट, उसको अपन माइनस करेंगे जस्ट।
The next question. Suppose student quick table. We have given a table. Suppose student lab infrastructure satisfaction score are good into intervals with the following district. Compute an approximate median satisfaction score for the student. अपन को मीडियन स्कोर निकालना है। इसकी जो मीडियन क्या होता है, बेसिकली मीडियन मिडिल मोस्ट टर्म रहती है, तो हमको सबसे पहले इसको अरेंज करना पड़ेगा, उसके बाद सम करना पड़ेगा जितनी भी टर्म। सपोज ये 6 टर्म्स है तो इवन फार्मूला यूज होगा, ऑड के अंदर n+1/2 यूज होता है, but in even we will use n/2 term plus n/2 plus 1 term, and by adding them we'll divide by 2. So computing the mean uh, frequency, cumulative frequency. What's cumulative frequencies? Sum of frequency and their above frequencies known as cumulative frequency. So we have made a table of cumulative frequency, and we need to correct the class boundaries 0 side 0.1 0.5 and add 0.5 to upper. From lower we will subtract it, from upper we will add it to make them continuous हो पाए, and find the cumulative frequency निकाली। अब total students number is 3194, and the median position n by 2 is 1597, and the number closest to it is 1500, so we will select 2450. So our median class will be 21, between 21 and 50. We'll apply formula, n क्या निकला अपना 314994। L is the length की कितनी लोअर बाउंड्री से अपर बाउंड्री कितनी उसमें है, तो वो 20.5 है ऊपर अगर देखेंगे आप। ओके, देन क्यूमुलेटिव फ्रीक्वेंसी इस अबो वाले की देखेंगे, इससे ऊपर वाले की, तो 950। देन फ्रीक्वेंसी विल बी 1500, और h जो है इसकी हाइट जो है वो 30 है, तो विल कैलकुलेट द मीडियन विल बी आर 33.43. So in this way we'll solve this question, kind of easy question. Now moving forward to the next question. In Department of Lifelong Learning, a feedback survey collected both the students' age and their self-assessment of productivity for 18 students. 18 स्टूडेंट्स का हमको दे रखा है। कैलकुलेट मीन मीडियन मोड एंड स्टैंडर्ड डिविएशन of age and percentage productivity. Draw box plot of both and scatter a plot and QQ plot to study the relationship. We have given 18 students. Some for mean we will simply sigma fi xi formula, will use that formula. Age data is sorted. Okay, so we got the data in sorted order, so no need to arrange it directly, we can solve it. So mean will be sum of all the age plus their percentage, so that will be the 836 divided by 18, that's approximately 46.44 years. Median will be 18th term है, तो 18th term का n by 2 9 प्लस n by 2 प्लस 1 10, 9th और 10th term को हम प्लस करेंगे तो उसका एवरेज निकालेंगे। 50 प्लस 52 इट्स 102, 102 divided by 2 51. So this is median. Standard deviation simply means how a data is deviating from the mean value. Okay, so we'll subtract every value with mean and sum of them. So calculate approx 12.9 showing high spread. Productivity, प्रोडक्टिविटी का जो मीन है, फॉर प्रोडक्टिविटी वी हैव आल्सो गिवन द ग्राफ जिसके अंदर पॉइंट वैल्यू दे रखी है, ग्राफ सॉरी आई मीन टेबल। then again the mean will be sum of all them divided by 18, which will be approx 28.5, and median middle value for scoring both the approx value, which is 29.5. Now we'll plot box plot. So basically average age box plot will show negative weakness, mean 46.4 less than median. The tail is on the left, younger ages. Productivity box plot, check of outliers in efficiency. So this is our box plot. Now QQ scatter plot. X-axis will be our age and y-axis will be percentage, productivity percentage. Observation, as an increase of age 20 to 63, the productivity roughly increases. And interpretation, positive correlation, older students self-assessed higher productivity. ओके, क्या हमको पता चला, जैसे जैसे एज बढ़ रही है प्रोडक्टिविटी बढ़ रही है. एंड पॉजिटिव कोरिलेशन है कि जैसे जैसे एक्सपीरियंस हो रहा है वो बहुत अच्छा प्रोड्यूस कर पा रहा है. नाउ क्यू क्यू प्लॉट, क्यू क्यू प्लॉट वही रहेगा, ऐसे ऊपर तरफ जाएगा क्योंकि बढ़ रहा है हमारा प्रोडक्टिविटी. और वो एज और नॉर्मल डिस्ट्रीब्यूशन है प्रोडक्टिविटी. एज के अंदर क्या है, जो मिडिल एज हमारे अपने मीडियन लिया है उसके ऊपर जैसी आ रही है वहाँ पे बढ़ रहा है ग्राफ. दिस विल बी आर क्यू क्यू प्लॉट. नाउ this was A section of our paper of first internals. It is divided into 4 sections. Now we'll continue to B section. Dissimilarities and similarities in feedback. So how to compute dissimilarities? Student feedback profile described by 4 attributes. First is nominal, which is department and elective. Second is asymmetric binary attribute, attend workshops. Third attribute will be tell about CGPA and attendance percentage. D will be term frequency vectors. So basically outline how to compute dissimilarity between student feedback profile, nominal, asymmetric, binary, numeric and term frequency. Nominal के अंदर जो formula we use p minus m divided by p. P is the number of variable and m is number of matches. If its method is simple matching, if the value matches, distance is 0. If different, difference distance is 1. Okay. Asymmetric binary attribute is all about method of the method we use is Jacquard's method, which ignores negative value. अगर positive negative positive we will accept it as q. R will be positive negative and s will be negative positive. No yes. Okay, formula will be r plus s divided by q plus r plus s. q क्या था हमारा, yes yes. R जो था हमारा yes no and s will be no yes. Moving to the third, numeric attributes. Euclidean or Manhattan distance we calculate in this. Normalization, crucial to normalize data z score for the so large values. Don't dominate small values, CGP 9.0. Method cosine similarities, formula 1 minus similarity cosine. We measure the angle between rather than vectors rather than the distance, as document length shouldn't matter. Just a second, let me check whether I have explained the previous question. Yes, I have done it. Okay. Now to the next question. Suppose two student faculties interaction profiles are represented at tuple 2, 1, 4, 42 and 10, 22, 1, 42, 10 and 20, 0, 36, 8, where a present hour is spent in mentoring project reviews attend and submitted infrastructure usage. So first we have to find Euclidean distance, Manhattan distance and Minkowski distance with h equals to 3 and supremum distance. So computing it, tuple 1, tuple 2 have been given. So distance 1 will be the distance between the first elements, as both have 4 elements. So d1 will be 2, d2 will be 1, 6, 2 respectively. Now Euclidean's method. For Euclidean, formula is simple, sum of all the distance chi square. So its distance will be root 45, which is equals to 6.07. मैनहट्टन का फॉर्मूला क्या होता है, मॉड्यूलस ऑफ डिस्टेंस का हम सम कर देते हैं. So it will be 4 plus 1 plus 6 plus 2. Why we have used 4? Okay. L1 norm says के. Okay. So the distance will be 11. और आई गेस 8 would be used क्योंकि 2 वो है तो वहाँ पे 2 आएगा instead of 4. मैंने वो उसकी डिस्टेंस h equals to 3. So h जो है it's a value of root and square. तो 2 square plus 1 square plus 6 square plus 2 is 3. Sorry, 2 cube plus 1 cube plus 6 cube plus 2 cube, which will be 8 plus 1 plus 2, 16 plus 8, root 233, which is 6.15. Supremum distance maximum between the 2, 1, 6, 2, जो कि 6 है. तो as 6 is repeating, so our distance will be 6. Now, going to the seventh question, the median score is often key holistic indicator of faculty or infrastructure performance. When dealing with massive student feedback dataset, purpose method of median opportunity approximately analyzes their complexity and suggests to balance accuracy and efficiency. When dealing with massive data, feedback dataset, purpose method of median approximation, analyze complexity and suggest heuristics. प्रॉब्लम क्या है? फाइंडिंग द एग्जैक्ट मीडियन रिक्वायर्ड सॉर्टिंग ऑफ एंटायर डेटाबेस। पूरा डेटाबेस जो है उसको हम सॉर्ट करना पड़ेगा। कॉम्प्लेक्सिटी क्या है? सॉर्टिंग टेक्स 0 एन लॉग एन, ये टाइम कॉम्प्लेक्सिटी है विच इज थोड़ा टाइम लेती है वो। फॉर मैसिव डेटा वी कैन नॉट लोड एवरीथिंग इनटू रैम और टू सॉर्ट रैम पे एकदम से लोड पड़ेगा। So, proposed method will be histogram or binding method. We approximate divide range into bins, which is bucket. Count items in each bin. Then estimate median using interpolation, like we did in question 3. कॉम्प्लेक्सिटी 0 n, इसमें टाइम कॉम्प्लेक्सिटी जो है कम है। सिंगल पास टू काउंट। Okay, then sampling, random select a subset of a data and find its median. Heuristics, the median of random sample is good. Estimators of population median. Heuristic for balance, accuracy versus efficiency. So the remedial algorithm, iteratively compute median of small batches, efficient for streaming data. Quantile digest data structures that store approximation ranks for information using very little memory. Okay, moving to the next question, question number 8. Eighth question. Given a data set of 5 students S1 to S5 as a query, x equals to 1.4, 1.6, a rank existing student by similarity, b, a normalized vector to use length and decompute. So this is the table we have been given, S1 से S5 तक, A1 and A2 for A1 and A2 students. So ranking will be basis of query जो है हमारी वो 1.4 and 1.6 which is the value of x students। जो S1 की वैल्यूज है वो S1, S2, S3, S4, S5 की रिस्पेक्टिव ये है। स्टेप ए, रैंक बाय यूक्लिडियन डिस्टेंस। यूक्लिडियन डिस्टेंस का फॉर्मूला क्या होता है? अंडर रूट ऑफ सम ऑफ डिस्टेंस। यस, सो डिस्टेंस 1 जो हमारी निकलेगी दैट विल बी 1.5 minus 1.4, will subtract 1.4 from all the values of a, like a part in S1, S2, S3, Sn, and 1.6 from Sb. Okay, so for S1 it will be 1.0.141. So this is the following values which we'll get. So we'll rank this. The 1.141 is the closest value to our value. Okay, then 0.23 3 जो सेकेंड वैल्यू सबसे लीस्ट है तो हम उसको सबसे लास्ट में रखेंगे। S4 0.68 विल बी सेकेंड क्लोजेस्ट, उसको हम उसमें रखेंगे। थर्ड S3 0.282, देन S5 0.670, देन RS2 use unit length normalization. Formula will be V new equals to V by m mod of mod V. Goal, scale vectors so their length magnitude is 1. Formula, example of S1 1.5 1.7, magnitude and normalization। 1.5 का S1 क्या रहेगा? Will sum the square of both the numbers and put them into root, that will be 2.267। we perform this all the vectors, this for all the vectors and the query x, then recalculate Euclidean distance। Okay, so S1 जो distance निकला that will be divided by this 2.267, which will be approximately 0.66 and 0.75. So this was our part B. Now moving to the part C. Faculty feedback data. So C part which will be our data processing for feedback analysis. Students faculty feedback may data may suffer from issue like accuracy, completeness, consistency. Discuss each issue in this context. Propose two other dimensional of data quality relevant to learning. So what's the question number 9? Discuss the issue like accuracy, completeness, and consistency in student faculty feedback. Propose two other dimension of data quality. So first accuracy correctness जिसे हम बोलते हैं issue, student might mark random answer just to complete the survey. A student gives 5 by 5 star, but right teaching was poor. In comments, this is inaccurate data. Completeness, a optional field left blank. A student reads the subject knowledge but leaves the communication skill. He's filling one and he's leaving one. Consistency, different scale and or conflicting formats. For survey uses a scale of 1 to 10, another 1 to 5. Merging them corrects inconsistency. Now, two additional dimension will be timelessness. Is the data current? Feedback given 6 months after the semester ends is useless for immediate improvement. Validity and uniqueness are there are duplicate entries. Example, one student submitting the form twice to skew rating. रेटिंग बढ़ाने के लिए दो बार फॉर्म सबमिट कर रहा है या बिगाड़ने के लिए. Okay, then moving to the next question. Handling missing feedback values. Discuss approaches such as ignoring tuples, filling manually, filling with constant mean, median, mode, imputation, class specified. Okay, so handling missing student values. Discuss approaches such as ignoring tuples, filling manually, filling with constants, mean, median, mode, imputation, class, and all. So in this, discuss approaches such as ignoring tuples, filling manually, and constant, mean, median, imputation, classes, specific imputation, etc. So method one, ignore the tuple, delete row. Action, delete the student's record completely. Pros will be simple. Consequences, loss of some value or valuable data only recommended if database is huge or missing values are few. Second, fill manually. Action will be checking the hard copies or the ask the student. Consequences will be tedious and impossible for large database. If we have a large database, we cannot check the hard copies manually one by one. Third will be fill the global constant. Replace missing value with the unknown or minus one. Generally in the linked list which we have studied in DSA, we use minus one as the empty spaces. Similarly in this consequences, the algorithm might mistake minus one for real low score. Okay, so it's better to use NIL or unknown. Method 4 will be central tendency. Action replaces missing rating the with average rating of the class. Pros will be preserve the overall mean and cons will be reduce variance. So variance रहेगा distance from the mean will be reduced, which might uh, which might result in faults. Method 5, class specific imputations. Instead of global average, use the average of student in the same development department semester. Pros will be more accurate context. Sixth, most probable method value prediction. Use regression or decision tree to predict the missing value based on other answers. Most accurate method. Okay. Now moving to the question 11. Actually, in this we have 12 as well as 13th, and I guess 14th is the last. Then 15th, 16th, 17th, 18th will be of part D. All right, the C section is quite bigger section, and 19th one is the only part. Okay, moving back to the question we were discussing. Okay, resolving conflicts, we have gone through it. Discussing normalization method, minimum maximum normalization, z-score normalization, z-score normalization using mean absolute deviation, then decimal scaling. So question number 13 we'll be discussing about it. First is minimum maximum normalization. Rescale data to fix range, usually between 0 to 1. Formula will be v dash equals to v minus minimum a, maximum a divided by maximum a minus maximum minimum a into new max minus new min plus new min. What's the positive signs? Pros, preserves all relationship at exactly. Outliers can squash the rest of data into a tiny ranges. Z-score normalization, moving to the next, zero mean. Rescales data based on mean, mu and standard deviation sigma. formula will be v dash equals to v minus mu divided by sigma. Pros handles outlier better than min-max using when actual min-max are unknown. Z-score using mean absolute deviation used when standard deviation is too affected by extreme outliers. Formula will be v dash equals to v minus mu upon my SA, where SA equals to 1 by n sum of v minus mu. Decimal scaling, move the decimal point of value of attribute A. Formula will be f dash equals to v by 10j. The maximum vj should be less than 1. Moving to the next question, question number 14. Question: normalize the following faculty workload values hours per semester: 200, 300, 400, 600, 1000 using A minus D. Normalize the value 200, 300, 400, 600, and 1000. Statistical calculation data will be 200, 300, 400, 600, 1000. N equals to 5. Minimum value equals to 200. Maximum will be 1000. Mean will be mu 200 plus 300 plus 400 plus 600 plus 1000 divided by 5 equals to 2500 divided by 5, which is 500. This is our mean, sum of all data upon number of data. Then standard deviation का formula होता है x minus mean x minus mu upon में n, x minus mean का whole square सब sigma. So यही formula हम use करेंगे. By using this formula we will be getting the value of 240. And absolute deviation formula will be getting 28.282.8. Second step, apply normalization. Mean, median, mean, maximum normalization ranges 0 to 1. Formula 200, for 200 it will be 0 divided by 800 equals to 0 0. Formula जो हम यूज करते हैं v minus 200 upon में 1000 minus 200 equals to v minus 200 upon में 800, which will be the value. So तो हम v को उधर रहने देंगे, then we'll calculate it. 600 it will be 400 by 800, 0.5. जो वैल्यूज आ रही है v की हम उस पर रखते जाएंगे. 1000 minus 200 which will be 800 divided by 800 1. तो ये हमारा रहता है अप्लाइंग नॉर्मलाइजेशन, मीन मैक्स नॉर्मलाइजेशन. देन z को नॉर्मलाइजेशन फॉर्मूला विल बी v माइनस 500 अपॉन में 28.2, v 200 है तो माइनस 300 अपॉन 28.2 विल बी माइनस 1.06. 500 के लिए 0 होगा, 1000 के लिए 500 बचेगा विच विल बी 1.77. z स्कोर विद एम ए डी, म्यू जो है हमारा 500 है और ऐसे जो है हमारा 240 है. सो वी विल यूज फॉर्मूला v माइनस म्यू दैट इज 500 डिवाइड बाय ऐसे विच इज 240. 200 की वैल्यू रखेंगे माइनस 300 बाय 240 विच इज 1.25. माइनस में 1000 के रखेंगे तो 500 डिवाइड बाय 240 इट्स इक्वल्स टू 2.08. Decimal scaling, maximum value is 1000. To make it less than 1 we divide by 10 to the power 4, 10,000. 200 की वैल्यू जो रहेगी वो रहेगी 300 divided by 240 which is 0.2. 1000 की रहेगी 0.1. This was question number 14th. Okay, 15th, using the feedback rating dataset, normalize the value using 35. So